All right, hey everybody. We're going to go over the quizzes and the quiz retakes. We're going to go over quiz A first. So number 1 was you have to write the molecular equation. It was lithium sulfate, solutions of lithium sulfate and calcium nitrate are mixed together. Write the balanced chemical reaction with phases. So this is where you use your Foursquare. Now I covered this in the remote learning. If you don't remember it, I suggest you go back and find my lecture and watch it again. So anyway, lithium sulfate, you have to worry about your charges. So lithium is Li plus 1. Sulfate, not sulfide, but sulfate is SO4 minus 2. Then you've got calcium nitrate, and calcium is a plus 2. Nitrate is NO3 minus 1. Notice that it is not nitride, but it is nitrate. So you're going to go across for your reactants. So Li plus 1 and SO4 minus 2. You swap your charges and you get Li 2SO4. Now the problem said that we have solutions. So Li2SO4 is aqueous. And then calcium nitrate, Ca plus 2 with NO3 minus 1 is going to be Ca parentheses NO3 parentheses 2, and we got that to be aqueous as well. And then to predict the products, you are going to go diagonally down. So Li, you're going to switch the cations basically. So Li is going to be with the NO3. So Li is a plus 1, NO3 is a minus 1. So you have LiNO3. And then the Ca plus 2 is going to be with the SO4 minus 2. So that would be CaSO4. And we don't know the phases yet until we use our solubility rules, but we need to balance this reaction, and it's as simple as putting a 2 in front of the LiNO3. Now, using the solubility rules, you look up the anion and see if it is soluble and see if your cation is an exception. If your cation is an exception for your anion being soluble, then it's a solid. So you look up NO3 on the solubility rules. NO3 is soluble always. There are no exceptions to nitrates being soluble. So LiNO3 is aqueous. And then you look up the CaSO4. The CaSO4, you look up the SO4. SO4 is soluble except when bonded to the calcium plus 2 ion. Therefore, CaSO4 is insoluble. That would be a solid. Now, number 2 was to write the complete ionic and net ionic equation for the balanced chemical equation that I gave you. Now, what you're going to do is you are going to split up all of the aqueuses. Now, unless they are polyatomic ions, you are going to kick the subscript out and make it a coefficient. So we have FeCl3 It is aqueous, so we're going to split up all of the aqueuses apart. So we've got Fe, and it's a charge of +3 because the Cl is a -1. So we've got Fe plus 3 aqueous plus 3 Cl's -1 aqueous. Now notice that it is not Cl3 because if you put Cl3, I assume that it is 3 chlorine atoms bonded to each other. That's not the case. We have 3 chloride -1 ions in solution, and they're all broken apart. So that's why we put 3 Cl -1. And then the 3 NaOH is aqueous, so we are going to split that apart into 3 Na, keep our balancing. That's why we keep our balancing, and that's aqueous. Now the 3 also applies to the OH. So we've got 3 OH -1 aqueous. Yielding, now we come to our solid, the FeOH3. Solid. So we are going to keep our solid exactly the same. So we're just going to copy that down in the FeOH parentheses 3, solid. And then the 3 NaCl is aqueous, so we are going to split that apart into 3 Na plus 1 ions, aqueous, plus 3, because of the balancing refers to all of the elements in that compound. So the 3 Cl -1 ions. So now we cancel out our spectator ions. Our spectator ions are the ions that are that are exactly the same on opposite sides. So we've got the 3 Cl -1, we've got 3 Cl -1 on the other side. So the 3 Cl -1s are spectator ions. And then we've got the 3 Na plus 1 and the 3 Na plus 1. So those are spectator ions as well. So those get canceled out. And then the net ionic equation is just what you haven't written. So whatever you haven't canceled out, I mean. So we get Fe plus 3 aqueous plus 3 OH -1 aqueous yields Fe OH3 solid. Now, one thing that you have to realize is that matter is conserved. You have the same number of atoms on one side as you do the other side because we have carried our balancing through the complete ionic equation. If you don't have it balanced, then it's wrong. Okay? And precipitation reactions, you're always going to find 2 pairs of spectator ions, and you're going to be left with 2 ions, a positive ion, a cation, and an anion, a negative ion, and you're going to form your solid. Notice how charge is also conserved. We have a +3 ion in Fe plus 3, but we have 3 OH -1 ions, so we have a total of -3 from the hydroxide ions. Therefore, +3 -3 is neutral. We end up with a neutral compound as our product. So let's move on to quiz B. Quiz B. We've got number 1. Solutions of calcium hydroxide. And sodium sulfate. Are mixed together. Write the balanced reaction with phases. So we've got Ca plus 2 with OH minus 1 and sodium sulfate Na plus 1 with sulfate SO4 minus 2. So we've got a cross for the reactants. So Ca plus 2 with OH minus 1 is Ca OH 2 aqueous because it says it's a solution. And then the NaSO4, Na plus 1 with SO4 minus 2 is Na2SO4 aqueous because it says solutions. And then we go diagonally down for our products and diagonally up. So Ca plus 2 is with SO4 minus 2. So that's going to be CaSO4 plus Na plus 1 with OH minus 1, NaOH. Balance this, very easy. All you need is a 2 in front of the NaOH. And then we need to determine our phases. You've got CaSO4. SO4 is soluble, but when bonded to Ca, it is insoluble. So that is a solid. And then hydroxides are usually insoluble, except when bonded to an alkali metal, which is group 1 of the periodic table. So Na is in group or column 1 of the periodic table. So the NaOH is soluble, and that is aqueous. Then the number 2, write the complete ionic and net ionic equation. We've got 3LiOH aqueous plus AlCl3 aqueous yields 3LiCl aqueous plus AlOH3 solid. So the complete ionic equation, no different than quiz A. We are going to break up all of the aqueuses, keeping our balancing and everything. So 3LiOH aqueous is going to be split apart because it is aqueous. So we get 3Li plus 1 aqueous. And the 3 also refers to the OH. So we get 3OH minus 1 aqueous plus Al. We have an aqueous, so we split it apart. So Al plus 3 aqueous. And now this subscript of 3 is going to be kicked out as a coefficient because we have 3 chloride ions floating around in solution, not 3 chloride atoms bonded together as a chunk. And then we get 3LiCl aqueous, so we break that apart in the 3Li plus 1 aqueous, and that 3 also refers to the Cl's, So we get 3Cl minus 1 aqueous. Plus, now we come to our solid, AlOH3 solid. So we are going to keep that together. All right. And then the net ionic equation is just you cancel out the spectator ions, whatever is the same on both sides of the reaction. So we've got the 3 Li plus 1 and 3 Li plus 1. So those are spectators. And we've got the 3Cl minus 1 and the 3Cl minus 1. So the 3Cl are spectators as well. And then now just rewrite what you have. So that would be 3OH minus 1 aqueous plus Al plus 3 aqueous yields Al OH 3 solid. So that's the quiz review. Hopefully by now you have learned this. We will retake the quiz if you got 20 points or below. And it's not going to be the same quiz though, because you've already seen both quizzes. So what I expect is for you to have taken notes. If you have not taken notes over this, you need to go back, rewatch the video, and copy down exactly what I have on the board, and then go from there. If you have any questions, I'm here during homeroom. I'm happy to help, but it's kind of on you to watch this video. So thank you very much for learning with me today. I enjoyed learning with you.